In the early days of World War II, as the skies above Europe and the Pacific became battlefields of metal and fire, aircraft designers raced against time, desperate to produce fighters that could dominate the skies. Among these engineers and pilots, a remarkable machine emerged from the workshops of Lockheed, the P-38 Lightning. Unlike any fighter before it, the P-38 was a twin-engine, twin-boom aircraft, a radical departure from the single-engine fighters that had dominated the previous decade. Its unique design made it instantly recognizable, and more importantly, it carried within it a technological promise that would leave both allies and enemies astonished. The story begins in the United States, where Lockheed's engineers were under immense pressure. They needed a fighter that could excel at high altitudes, possess long-range capabilities, and maintain speed and firepower superior to the Axis planes. The result was the P-38, a sleek aircraft with a futuristic look, gleaming in aluminum skin, housing two powerful Allison B-1710 engines. But it wasn't just about appearance. The P-38's engines were connected through a complex system that allowed for incredible stability, reliability, and performance. While many contemporary planes struggle with overheating or engine failures, the P-38 seemed almost untouchable in this regard. By the time it entered combat, the P-38 had already earned a reputation. Its long-range capabilities allowed it to escort bombers deep into enemy territory, and its firepower, a concentrated nose-mounted array of cannons and machine guns, made it deadly accurate. Pilots who had flown other fighters often found themselves struggling to match the performance of the twin-engine behemoth. Reports from the European and Pacific theaters began trickling back, tales of P-38s diving faster, climbing quicker, and sustaining damage that would cripple lesser aircraft. Yet, the true marvel of this plane lay not in anecdotes or speculation, but in its engineering, the heart of its power, the twin engines. Allied engineers, those who meticulously studied every captured aircraft or emerging prototype, were no strangers to innovation. They had seen impressive German engineering in the Messerschmitts and Focke-Wulfs, and even the Japanese Zero had demonstrated the deadly efficiency of lightweight design. But the P-38 presented a different kind of challenge. Unlike the Axis fighters, whose designs were mostly single-engine with conventional layouts, the P-38's twin-engine system was a carefully orchestrated ballet of engineering brilliance. Each engine worked in perfect harmony with the other, allowing for both raw power and precision control. The curiosity of these engineers reached a peak when reports suggested that the P-38 could maintain stability even if one engine was damaged or destroyed in combat. This was almost unheard of at the time. Single-engine fighters, if hit in the engine, often became uncontrollable, spiraling to ground within seconds. The P-38, however, could continue to fly, maneuver, and even complete missions on a single functioning engine. This wasn't just a technical feat. It was a revolutionary leap in aerial warfare. Allied intelligence officers knew that understanding this machine could provide valuable insights for their own aircraft design and strategy. To fully grasp the marvel, we must step back and examine the environment in which the P-38 was born. The late 1930s and early 1940s were a time of rapid technological change in aviation. Engine performance, aerodynamics, and materials science were advancing at an unprecedented pace. Lockheed's engineers had the advantage of working with Allison engineers, who supplied the innovative V-1710 engines. These engines were liquid-cooled, which allowed for a slimmer, more aerodynamic profile than air-cooled counterparts. This design reduced drag and improved speed and climb rate. But more than that, the engines were designed to deliver consistent power at altitudes exceeding 30,000 feet, a realm where many fighters of the era struggled to maintain efficiency. This combination of aerodynamic sophistication and engine innovation made the P-38 unlike anything the Allied engineers had seen. It wasn't merely a faster or more powerful fighter. It was a machine that embodied the next generation of aerial combat principles. Its twin-engine layout also allowed for redundancy and survivability, concept that would later become foundational in the design of long-range bombers and multi-engine fighters. In the Pacific theater, where distances between islands stretched beyond the range of conventional aircraft, the P-38's extended range and reliability became invaluable. Yet, despite all the praise and admiration, there was an undercurrent of mystery surrounding the P-38. How exactly did these twin engines operate so flawlessly together? How could a single pilot manage such power without the aircraft becoming unstable or unwieldy? These questions gnawed at the minds of Allied engineers, who were determined to test, measure, and, if possible, replicate this advanced technology. Intelligence reports hinted at capabilities that seemed almost too advanced for the time: climb rates faster than the P-51s, dives that defied conventional limits, and an ability to sustain combat damage while still completing missions. The allure of the unknown, combined with the urgency of wartime innovation, set the stage for a dramatic revelation that would shock even the most experienced engineers. By the end of the war, the P-38 had proven itself in both the skies and in the engineering labs. Allied engineers who studied it could hardly believe the sophistication of its design. Its twin engines were not just a technical feature. They were a statement of what American innovation could achieve under pressure. The lessons learned from the P-38 would inform the next generation of fighter planes and influence aviation technology for decades to come. But before that, there was a story of fascination, of meticulous observation, and of sheer disbelief as engineers examined every bolt, cylinder, and turbine, uncovering secrets that had been hiding in plain sight above the clouds. The moment arrived when Allied engineers finally got their hands on a P-38, a captured aircraft that had somehow made its way from the front lines into the hands of intelligence teams. These were men who had seen the most advanced machinery of the era, who had dismantled engines from Messerschmitts and Focke-Wulfs, and yet the P-38 immediately commanded their attention. Its sheer presence was intimidating. Twin booms stretching out like mechanical arms, a central nacelle housing a cockpit that seemed almost more like a spacecraft than a fighter, and the unmistakable hum of two powerful engines waiting to roar to life. They began with careful inspections, studying every detail. The first thing that struck them was the precision of the engine layout. Unlike conventional single-engine fighters, where power flowed from one source to one propeller, the P-38's twin engines were engineered to share the workload seamlessly. Each engine had its own supercharger, allowing it to maintain efficiency at altitudes that would have choked most other fighters. The synchronization between the two was so flawless that it almost seemed sentient. Turning the controls, the engineers could feel how balanced the aircraft was. Every movement of the throttle and aileron resulted in predictable, controlled responses. Then came the test flights. Pilots assigned to fly the P-38 described sensations that bordered on disbelief. "It's like flying two planes as one," one report read. The engineers watched on the ground, not entirely sure what they were seeing. The plane accelerated with astonishing smoothness. In dives, it maintained stability without the tendency to shake or wobble. Climbing at high angles, the twin engines delivered power that no single-engine plane could hope to match. Even more extraordinary was the redundancy built into the system. Shutting down one engine mid-flight did not spell disaster. The plane remained controllable, able to continue toward its objective, as if mocking the limitations of conventional aircraft design. The engineers began running detailed tests. They measured fuel consumption, engine temperatures, propeller torque, and supercharger efficiency. Every test seemed to confirm what the pilots had already felt in the cockpit. The P-38's twin engines were more than just two power plants. They were an interconnected system designed for resilience, endurance, and performance. Unlike other fighters that relied on brute force, the P-38 relied on intelligent design. The engineers realized that Lockheed had not simply duplicated one engine. They had integrated two engines into a coherent whole, capable of compensating for the weaknesses of either unit. Beyond raw performance, the engineers marveled at how the P-38's engines handled stress. In combat, an aircraft could sustain damage from bullets, flak, or mechanical failure. Yet the P-38, even with compromised engine, could maintain altitude and maneuverability far beyond expectations. One test simulated engine failure mid-climb. The plane tilted slightly, adjusted naturally, and continued its ascent. Observers were speechless. The Germans, the Japanese, and even the Americans' own prior designs could not achieve such ability under duress. It was a lesson in engineering foresight. Redundancy was not an afterthought, but a core principle. The technical marvels didn't end there. The engineers discovered that the V-1710 engines were designed for high-altitude supercharging, providing more oxygen to the engine at heights where others would falter. Coupled with efficient intercoolers and a precise fuel system, the engines maintained power with minimal risk of overheating or knock. The plane's nose-mounted armament, combining 4.50 caliber machine guns and a 20 mm cannon, benefited directly from a centralized design, allowing pilots to aim with unprecedented accuracy without the recoil destabilizing the aircraft. Every detail was interconnected, an orchestration of mechanical harmony that demanded respect. As days passed, the engineers grew increasingly fascinated and increasingly uneasy. This was no ordinary fighter. Its capabilities were beyond what they had encountered, and there was a growing sense that understanding it fully would take more than just measurements and calculations. They began documenting every quirk: how the engines responded to rapid throttle changes, how the plane's center of gravity shifted during maneuvers, and how airflow over the booms influenced stability. Each revelation deepened the mystery. How had Lockheed achieved this level of integration at a time when other nations were still struggling with single-engine designs? The answer, they realized, lay in both ingenuity and relentless testing, a philosophy that treated every component as part of a living, breathing system. The P-38's twin engines also offered tactical advantages that surprised even seasoned engineers. In combat reports, pilots noted that the plane could outclimb almost any enemy fighter, perform high-speed dives without loss of control, and sustain damage that would have grounded other aircraft. In one legendary encounter, a P-38 returned to base with one engine destroyed and half of its fuselage riddled with bullets, proving the theoretical observations in dramatic real-world scenarios. For engineers, these were not just numbers on a chart. They were proof that the design principles they had uncovered could redefine aerial warfare. By the time testing concluded, the P-38 had left an indelible mark. Allied engineers documented their findings meticulously, creating technical reports that would influence post-war aircraft design. They could hardly believe that a single aircraft, produced under the pressures of wartime urgency, could combine such raw power, redundancy, and precision. The P-38 was not just an instrument of war. It was a symbol of what careful engineering, bold design, and visionary thinking could achieve. It was a machine that challenged assumptions, defied expectations, and set a new standard for fighter aircraft worldwide. And yet, the story of the P-38 was far from over. The lessons learned in those test flights, the secrets unlocked in every inspection, would culminate in one final revelation, an extraordinary climax that would cement the P-38's place in aviation history. The question remained, could any other aircraft match its combination of speed, resilience, and raw engineering brilliance? That answer would come only in the skies, in the hands of the pilots who dared to push this twin-engine marvel to its limits. As the engineers continued their tests, a sense of anticipation grew. They had dissected the engines, charted performance curves, and even simulated combat conditions on the ground. But nothing would prepare them for the moment when a pilot took the P-38 on a full demonstration flight. The plane roared to life, its twin engines thundering in perfect synchrony, vibrating through the air like a heartbeat made of steel and fire. Observers held their breath as it taxied down the runway, then lifted gracefully into the sky, almost as if defying gravity itself. The first climb was breathtaking. The P-38 shot upward, engines pushing beyond anything the engineers had expected. Altimeter needles spun, gauges rattled, and yet the aircraft remained perfectly stable. The pilot executed sharp turns and rapid maneuvers, and the twin engines responded instantly, adjusting power output without hesitation. One engine faltered mid-climb, intentionally throttled back to simulate combat damage. Instead of plunging into chaos, the aircraft adjusted automatically. The nose remained steady, the plane tilted but did not spiral, and the pilot maintained full control. For the engineers, the sight was almost surreal. Every textbook principle they had known about aircraft limitations seemed to shatter in that single moment. It was then that the true genius of the P-38 revealed itself. The synchronization between the engines was not merely mechanical. It was strategic. Lockheed had anticipated scenarios that no one else had considered: high-altitude interception, long-range escort missions, and extreme damage survivability. Each component, from the superchargers to throttles, had been designed not as separate parts, but as elements of an interconnected system. It was a revelation that transformed the engineers' understanding of aviation. Here was not just a fighter, but a blueprint for the future of aerial warfare. In one demonstration, the pilot executed a simulated combat dive from over 25,000 feet. The engines howled, wind screamed past the cockpit, and gauges spiked under immense pressure. Observers braced themselves, expecting to see the plane tremble, stall, or worse. Instead, the P-38 sliced the sky like a knife, maintaining perfect stability. Its twin engines absorbed the stress, distributing the load in a way that made a single-engine fighter appear primitive by comparison. The engineers whispered in disbelief. They had prepared for exceptional performance, but what they were witnessing exceeded even the most optimistic predictions. The tactical implications were staggering. A single P-38 can engage multiple enemy aircraft, outclimb and outmaneuver them, and return home even after sustaining serious damage. Its twin engines were not just a feature. They were a force multiplier, giving the pilot confidence to push limits and execute maneuvers that would have been suicidal in other planes. For the Allies, this was more than technology. It was a psychological edge, a weapon of both metal and morale. Yet, amid the triumph and awe, there was also a lesson in humility. The engineers realized that the P-38's brilliance was not merely in its engines, or its aerodynamic design, or even its armament. It was in the integration of all these elements, design, engineering, and testing combined into a single, unstoppable machine. The aircraft embodied a philosophy that innovation was not about isolated components, but about the seamless orchestration of every part working in harmony. When the testing concluded, the reports circulated among Allied design teams. They were filled with detailed observations, charts, and technical schematics, but they also carried a tone of astonishment. The P-38 had set a benchmark. Future aircraft, whether fighters or bombers, would inevitably be compared to this twin-engine marvel. Some features, like engine redundancy, would be copied and refined. Others, like the precise balance of power and maneuverability, would remain unmatched for years. For those engineers who had witnessed the flights firsthand, the P-38 was no longer just an aircraft. It was a symbol of what was possible when ingenuity met necessity under the crucible of war. Beyond the numbers and technical marvels, the P-38 also left an indelible mark on the pilots who flew it. Many recounted the sense of invincibility it provided in combat, the confidence that even if the worst happened, if one engine failed or flak tore through the fuselage, they could still return home. Tales emerge of extraordinary feats. Deep escort missions over enemy territory, lone interceptions against overwhelming odds, and flights that pushed the limits of both human and machine. Each story reinforced the engineers' findings. This was an aircraft built not just to survive, but to dominate. By the end of the war, the P-38 Lightning had cemented its place in history. It was a fighter that challenged the conventions of its time, a twin-engine marvel that astonished everyone who studied it, and a machine that bridged the gap between raw power and intelligent design. The lessons learned from its engines, its stability, and its integrated systems influenced post-war aviation and inspired a generation of engineers and pilots alike. The P-38 was proof that vision, innovation, and meticulous engineering could achieve feats that once seemed impossible. And so, as the sun set over airfields that had once echoed with the roar of its engines, the P-38 remained a testament to human ingenuity. It reminded the world that even in the chaos of war, extraordinary breakthroughs could emerge. Machines that defied expectations, redefined possibilities, and left engineers and pilots alike in awe. The twin engines of the P-38 were more than mechanical marvels. They were symbols of the courage, creativity, and relentless pursuit of excellence that defined an era of aerial warfare. In the end, the question was not whether the P-38 was powerful or advanced. It was whether the world was ready to witness the full potential of human engineering. The answer, it turned out, had been in the skies all along.